Hey everybody, today we're starting a new chapter. We've got section 5.3 and it's still a whole matrix chapter, so we're still using the concept of matrices and a bunch of different uses of them, but we have a new vocabulary word called determinant. That is this word here, and each matrix, if it is a square matrix, like these two that we have down here, has a number called a determinant that goes with it. And hopefully you can hear the nice birds in the background because yes, I'm sitting outside making this video. Okay, and the way that we write the determinant is we use these things that look like absolute value bars, like that. So it's commonly confused with absolute value, but if it has to do with a matrix, you can't really take the absolute value of a matrix. So actually that same symbol is used for the word determinant. And so what we have first of all is we have kind of a formula to find the determinant. So if we have this matrix here with these four elements in it, just denoted with A's for the time being, then the way you're going to find it is you're going to cross multiply, and you always start by going down. So I'm going to do A11 times A22. I'm going to write that over here. So we have A11 times A22, and then I'm going to subtract the other way, A21 times A12. So whatever those numbers are, you always start by going down. There's a Nelly song, I'm going down, down, baby. You know that song. So always start by going down. I like to think of that song when I'm doing these matrices. So whatever numbers those are, you just subtract the products. Let's do a couple examples so that it makes a little bit more sense. So I always start by going down. So I'm going to start with 12 times 2, which is 24, minus, and 3 times negative 6 is negative 18. Yes, that is a double negative, which means that you add. So we're going to do plus positive. This is going to give me 42. So this, remember what this is called. This number is called the determinant, sometimes abbreviated DET. Okay, so let's try the second one. Very simple process, it's just a formula. Always start by going down. So 11 times 3 is 33, minus, you go 4 times negative 2, it's negative 8. Another double negative, so be careful with that. And again, we have, ironically enough, the same number. Determinant is 42. Okay, so to find a determinant of a 3 by 3 matrix, there's actually two different ways that you can do it. Yes, you need to know how to do both, and just like the last test, you'll have to show me that you know how to do both ways. The first one is called the diagonal method, which we'll talk about in a second. But then for all the other problems, you can choose whichever one you like the best. So here's our steps up here that I have written down in order to find the determinant of a 3 by 3 matrix. The reason why we have a different way is because if you do a diagonal this way and you do a diagonal this way, then there are 4 different numbers that weren't even used. And unfortunately, the determinant of a matrix uses every single element of the matrix. So our very first step is to copy the first 2 columns on the right-hand side. I'm reading that from up here. What that means is I'm going to take these first 2 columns, this one, and I'm going to copy them right here and right here, which is a little bit strange, but not too difficult. So I'm going to go 2, 0, 3. That's just this column right here. I'm also going to use this column. So 1, 5, and 6. Can you hear the music next door? My neighbor is outside listening to music. Okay, so now the steps up above, let me go back so I can kind of refer to this. The sum of the 3 diagonal products going down. Again, you always start by going down, and then you're going to subtract the sum of the 3 diagonal products going up. So it's very similar to what we just did, except instead of just one diagonal, we're going to use 1, 2, 3 diagonals. We're going to multiply all those numbers together. So I'm going to kind of write this all out. It might look a little bit confusing for a second. I'm actually going to use the highlighter to show you the 3 diagonal products I'm doing first. Here's one, here's one, and here's one. And what I'm doing is just multiplying those numbers together. So I'm doing 2 times 5, which is 10 times 7, which is 70, plus, then I'm going to do this diagonal product, which is negative 6 when you multiply all those 3 numbers together, plus, and then I'm going to do this one, which is 4 times 0 times 6, which is 0. So I'm going to add all those up, and then again, like we did above, we're supposed to subtract. So now I'm going to do the 3 diagonal products going up. So what that looks like is, remember you got to use all the numbers. This times this plus this. Okay, so we're multiplying all those numbers together and adding those products together. So So my first product is 3 times 5 times 4, which gives me 60. My next product is 6 times 2 times 2. Nope, 6 times negative 2 times 2, so negative 24. And my last product here is 7 times 0 times 1, so 0. So all I have to do is add these numbers together. 70 plus negative 6 is 64, minus 60 plus negative 24 is 36. When I subtract those, I get 28. So the determinant of that 3 by 3 matrix is 28. So let's see what's coming next. It's a little bit of a tricky process. I forgot to fill in this number 3 up here. This is an easier method when there aren't as many zeros, when there aren't many zeros in the matrix. I'm going to fill that in. When there aren't many zeros in the matrix. So in this matrix here that we had, there was only 1 0, I believe. Therefore, I would want to do the diagonal method, and then I'm going to show you the second method, which is on the back. So go ahead and try these two matrices. I'm just going to work them out, and you can check your work with mine, but I'd like for you to give them a try. I'm going to work them out. I'm going to pause the video so you can just check your answers. Alright, you guys, so here we have the two solutions worked out for the determinants. Just keep in mind, some people get confused. Make sure that you understand what this notation means up here. Those absolute value bars, when you're given a matrix, mean find the determinant, which here's the diagonal method in order to do that. So remember, you take the first two columns and line them up right here, and then you start by doing your down products. So 3 times 4 times 2 is 24, 2 times 3 times 1 is 6, 0 times anything is 0, and you add all those numbers up, and you subtract your second sum, which is the products going up. So 0, negative 45, negative 4. You add those numbers up, and then do 30 minus negative 49, which gives you 79. And then for number 4, you might have been wondering, hey, wait a second, what do you do when there's A's and B's in it? Well, you do the same thing. Take the first column, line it up here, second column, line it up here, and then start doing your down products. So 0, 2AB, negative 6, and you add those numbers up. Those are not like terms, so you can't combine them. Subtract, now we'll do our products going up. This is negative 16, 0, and 5b. So that's what I have here. I distributed my negative sign here, and then just combine like terms. So 2ab, negative 5b, positive 10. The order that you write those numbers in doesn't matter as long as the signs are correct. Alright, so now what I'm going to do is show you the second method on how to do determinant. This example here, this matrix is the same exact one that we did above with the diagonal method, so our answer is going to be the same when we find the determinant. I'm just going to show you a different method. Some of you will like this method better, some of you will like the other method better. So I'm going to go through our steps up here. This is useful for 3 by 3 or larger, so that part is important. If you have a 4 by 4 matrix, you have to use this way because we can't do the diagonal method with 4 by 4s. Pick any row or column to expand by, and the key here is it helps to choose one with zeros. So that is going to be important. If you have a matrix that has a ton of zeros in it, it's going to be way easier to do this method than doing all the diagonals like we did earlier. Rewrite it using minor matrices. So you're about to learn what a minor matrix is. Talk about that in just a second. It's going to look a little bit strange. And then this sign chart over here is actually also very important. We have to remember to change the signs of all of these opposite terms. So we have an opposite term here, 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 and here. So negative sign means make it the opposite sign that it already is in the matrix. So think about kind of an example would be quadratic formula, and you know how quadratic formula is negative b plus or minus the square root, blah, blah, blah. Well, negative b doesn't mean negative, it means opposite. And that's exactly what it means here, is that these mean opposite. Okay, so what we're going to do here is I'm going to zoom in on this one matrix, and what we are going to do is I'm going to pick one of the rows that has a 0 in it. So I have two options here. I could choose this column because this has a 0 in it, or I could choose this row because it has a 0 in it. But you definitely want to choose one that has a 0 in it, otherwise it's not as efficient. So it doesn't matter if I use the column or the row. I'm going to use this just because I want to. It has a 0 in it. And so this plus minus chart over here, when I choose my row or my matrix to expand, which I'll explain what that means in a second, what I have to do is think about this plus minus chart. So the top left entry is always a plus, this is always a plus, and then the signs alternate as you go through the matrix. And so for this row that I have chosen, what I need to do is change the sign of this term and change the sign of this term. And so that's because that's where the minus signs fall, so that means whatever sign this is, I need to make it opposite, and opposite 0 doesn't really make any sense, so that doesn't exactly matter. And I also need to change this sign to opposite, so I'm going to change this to a plus. Okay, so that's how the plus minus chart plays into this game. We're only doing the plus minus chart for the row or the column that we have chosen. I'm not changing every single number to the opposite. I'm only doing the row that I have chosen. And make sure that row or column that you choose has a 0 in it. So here's what I'm going to do. I'm going to do 0 times some matrix plus 5 times a different matrix and plus 2 times a third matrix. This is the weird part. And do you think you know where the 0 and the 5 and the 2 came from? They came from right here. Why didn't I write negative 0? Because negative 0 is the same as positive 0. So I put the coefficient here of 0. I'm using this coefficient here, and I'm using this coefficient here. So now what goes in these little matrices? This is another tricky part. Find the 0 in the matrix, which is right here. I'm going to cover up the row and the column that the 0 has to do with. Literally ignore them, and then what are the numbers that you have left over? I have a 1, a 4, a 6, and a 7, and those numbers go in this matrix. This is called the minor matrix. That's what minors means. It's when you cover up a specific row and column of the matrix, and whatever numbers are left over are the numbers that you use in your little matrix. So let's fill in the minor matrix that has to do with 5. So my 5 is here, which means I'm going to ignore the middle row and the middle column, and what are the numbers I have left over? 2, 4, 3, and 7. And that's what I'm going to fill in this matrix for. 2, 4, 3, and 7. Make sure you keep them in the right spot. The 2 is in the top left, so it's staying in the top left. The 4 is in the top right, etc. And now find the 2, which I'm using here. So that 2 is in the middle row and the last column. So I'm going to ignore the middle row and last column, and the numbers I see are 2, 1, 3, and 6. So I'm going to go 2, 1, 3, 6. Okay, so from here, this is what we've already done. The whole reason you want to pick a row or a column that has a 0 in it is because 0 times anything is 0. So think back to what you know about what these bars mean. What do these bars mean that I put into my little formula here? That means determinant, right? And we already found the determinant. So what I'm doing is 0 here times the determinant of this matrix. So that means you start by going down always, 7 minus 24. Plus 5 times the determinant of this matrix, which is 14 minus 12, plus 2 times the determinant of this matrix, 12 minus 3. Okay, and again, the whole reason why you choose a row or a column that has a 0 or more than one 0 in it is because 0 times anything is 0. You don't even have to do that. I didn't even have to fill in the 7 times 7 minus 24. 0 times anything is just 0. So that's why you want to choose a row or a column that has a 0 in it. So now my determinant is going to be 5 times 2 plus 2 times, what would that be, 9? So this is 10 plus 18, which is 28. This is the determinant of that matrix. And let's double check. Remember how this was the same matrix as the one we did with diagonals above? Let's double check that and make sure we got 28 for that example as well. Where was it? Here. Boom, 28. So either method you use should give you the same answer. I'm going to do 2 more, and then we will do another one in class just to make sure that we understand down here the diagonal and the minors. We'll do these in class tomorrow. So I'm going to do the minors thing again here with this one. And remember, I'm going to choose a row or a column that has a 0 in it. So my options for this one is I could do either this top row or I could do this left or right column. And it doesn't matter. I did a row on the first example, so maybe I'll do a column on this example. So I'm just going to circle this. And remember the plus minus chart, I need to change the signs of any number that falls in that position where all the minus signs are. So this is plus, minus, plus, minus, plus, minus. Interesting, I need to change that to opposite whatever it is. And then plus, minus, plus. Okay, so the only number I needed to change was this 3. So now what I'm going to do is use those as my coefficients. So I'm going to do 0 times something, which doesn't matter, and then negative 3 times something, and then positive 2 times something. And remember, 0 doesn't matter. 0 times anything is 0, so you don't even have to fill in that matrix. That's why you choose rows and columns with zeros in it. Okay, so what goes in with this negative 3? The negative 3 is right here. And remember, you're only doing the plus-minus chart for the column or row that you choose. You're not filling in pluses and minuses for all the other numbers, only the coefficients. Okay, so find the negative 3, which is here. I'm going to ignore this middle row and this last column, and my numbers that are left over are 3, 2, 1, and negative 5. I'm going to fill those in. And then same thing with the 2. I'm going to ignore the bottom row and the final column. Those numbers left over are 3, 2, negative 1, and 4. And now I just have to do a couple determinants. So I have negative 3. Then remember, you start by going down, which is negative 15 minus 2. Negative 15 minus 2. And then this determinant is going to be 12 minus negative 2. Careful with the double negative. So now I just have to crunch that number. So negative 3 times negative 17, and positive 2 times, that would be a 14. This is 28, this is 51. Add those numbers together and we get 79. So that determinant of this matrix is 79. So you can see that it's useful with zeros. Otherwise, the diagonal method is probably the easier way. Alright, last one. You guys are going to like this one. So I'm going to do diagonal method again. Remember to choose a row or a column that has a bunch of zeros in it. I could choose this column, this column, this column, or I think the easiest one would be to choose this entire row. I'm going to choose this one because it's got the most zeros. And so with my plus minus chart, remember it starts with a plus, minus, plus, minus, plus, minus. And again, negative 0 and positive 0 doesn't make any difference. So I have 0 times some matrix, plus 0 times some matrix, minus 0 times another matrix. And what are you guys thinking here? 0 times anything is 0. 0 times anything is 0. 0 times anything is 0. Technically, I guess these should be negative zeros, but again, negative 0, positive 0 doesn't make a difference. Our determinant here is 0. So it's important to note that anytime you have a row or a column that has all zeros, the determinant is going to be 0 no matter what. If it has any row or column of all zeros, then the determinant is always going to be 0. Okay, you can do that with the diagonal method too. If you do the diagonal method, think about copying this column here and this column here, and then doing all of your diagonals. There's going to be a 0 every single time in all of those diagonals, which is going to make your determinant 0 no matter what. So that's important to note. Thank you guys for watching. Bring your questions to class tomorrow. We're going to do these two examples down here, the minors and whatever else. We'll do those in class to make sure everybody's cool, and then you'll have time to work on some Math Excel. So thanks for watching. Have a good rest of your night.